Hello and welcome to Quick Maths Revision, where today we're going to be going through a guide on rationalising the denominator, and this is for GCSE 9 to 1. So if you haven't already seen, I've already done a video on the basics of working with surds, and this video will actually use some of the stuff that's covered in that, so be sure to check that out if you haven't already, and then come back to this if that's what you're wanting to do. So what we'll do is we're going to go straight into it. Rationalising the denominator it sounds more complicated than it actually is. What we're doing is we have a fraction with a surd in it, and what we want to get it into its nicest possible form, which is where the denominator, so the bottom of the fraction, doesn't have a square root in it anymore. So as we've seen in the previous video, you can divide fractions, and you can divide fractions by whole numbers as well. So root 3 over 2, root 7 over 4, root 2 over 9. All of these we'd say are in quite a nice form because the denominator of each of these is a whole number, which is what we want. We don't really like it when you have surds on the bottom of fractions. There's nothing wrong with it, it's mathematically correct, it's just as a form isn't too nice. So what we can do is, if we have a look at an example of not nice form, we'll see how to get it into the nice form. So if you've worked with trigonometry or done any maths using trigonometry, you may have seen 1 over the square root of 2 before, which is cos of 45 and sine of 45. But what you can see is that because we've not got a whole number on the bottom, this would be deemed as a more ugly form than in these previous examples. So what we're going to do is we're going to learn how to get rid of this square root on the bottom. And if you remember from the last video, there's a trick that if you have a surd divided by itself, that's 1, which just follows by basic algebra and just general maths, that if you had 1 over 1, that's 1, and if you had 4 over 4, that's also 1. And we're going to use that trick to rationalise the denominator. So what we do is we're going to get our fraction, which has got a surd on the bottom, and then we're going to multiply by the denominator over itself. So what you can see is that this term here, which has got the red brackets around it, that's 1. So what we've got is we've got a number, we're timesing it by 1. So what we'll see is that the answer is exactly the same. We're just going to move the surds around. So what we'll get is we'll get 1 times the square root of 2 on the top, and then we're going to have the square root of 2 times the square root of 2 on the bottom, which is root 2 over 2. And this is equivalent to this. And what we'll see is that this is deemed as the nicer form, but both of them are completely valid as a number. They are the same number. And all we've done is we've just moved that square root so that it's on the top and we have a whole number on the bottom. So let's do another example of this. 6 times the square root of 2 over the square root of 3. So what we're going to do is we're going to use the same technique again, multiply by 1, but make sure that you don't get confused because we've got two different surds. We're going to multiply by the 1 on the bottom over the 1 on the bottom. Brilliant. So what we're going to do now is we're going to just follow this through like we would normally. 6 root 2 times by root 3 over root 3 times by root 3. There we go. And then what we'll do is we'll use our method from last time, combine that, and then root 3 times root 3 is 3. And then we're going to have 6 root 6 over 3. So what you'll see is we've got a whole number on the bottom, but what we can do is we can simplify this further, make that into a 2, and the answer is going to be 2 root 6. So that's a considerably nicer form than 6 root 2 over root 3. We've just got 2 root 6. And if you're not sure as to why this has definitely been rationalised, this is the same as 2 root 6 over 1. And as you can see, 1 is the whole number in this case, and we've got rid of all of our surds on the bottom. So this method that I've just shown you for multiplying by 1 in each case only works for if the denominator has just a fraction on it, just a surd on it, sorry. Things get a bit more complicated if you have a mixture. So just to show this, if you have 2 over 1 minus root 3, we'll say not do this. So this is wrong. So if we try and use the technique we had before, we multiply by root 3 over root 3, because that's the surd on the bottom, we'll get 2 root 3 on the top, which is good, and then on the bottom we're going to get root 3 times 1 minus root 3, which is 2 root 3 over root 3 minus 3. So even though this and this are equivalent, we've not rationalised the denominator simply because we've still got this square root of 3 on the bottom. So this method does not work like that. Instead, what we're going to have to do is we're going to have to use a slightly different variation of the same method. So if we have the old fraction again, 2, 1 minus root 3, what we're going to do is we're going to multiply by 1 again, but in this scenario we're going to have a slight change that you take the denominator and then you just flip the sign before the square root. So this term here is still 1, but by using this flipping of the sign, this will solve the problem of what we had before, which was that you still had a square root on the bottom. So what we'll do is just follow this through like you would normally. 2 times 1 plus root 3. Then on the bottom we're going to have, if you do 1 times 1, you're going to get 1. If you have 1 times plus root 3, you get plus root 3. If you have minus root 3 times 1, you have minus root 3. And if you have minus root 3 times root 3, you get minus 3. And then what you can see is that this and this cancel. And that's what this step of flipping this sign has done. It's helped us to cancel out all of the root 3's on our denominator. So then what we've got is 2 times 1 plus root 3 divided by 1 minus 3 minus 2. And then what we can do is the 2 and the 2 cancel, and that becomes a minus 1. And you could leave it like that, or dividing by minus 1 is the same as timesing by minus 1. So you can have minus 1 plus root 3 as our answer, or if you want to get rid of those brackets, minus 1 minus the square root of 3. And that, as you can see, solves our issue that we don't have any surds in the denominator, as our denominator in this case, similar to the other one, is 1. So that's good. And that's really all the tricks that you'll need to learn for rationalising the denominator, but I'll just do another example and I'll show you one instance that they may try and trick you in an exam. So if you had, the most complicated example that I can think of is if you have a mixture of whole numbers and surds on the top and the bottom. So you had 7 plus root 11 on the top, and then on the bottom you had root 3 plus 2. Now this is where they'll try and catch you out, that if you've spotted here the denominator, I've written it the other way round to the way I did it in the other example. So in this example here is 1 minus the square root of 3, and in this one is root 3 plus 2. So what you need to do is you need to make sure that it is the sign of your square root that you're changing. So you don't want to put root 3 minus 2 over root 3 minus 2, because then your square roots won't cancel out. Instead, you might want to rewrite this question so it looks like this. 7 plus root 11 over 2 plus root 3. That way you're not going to get confused with which one you're going to be swapping. Anyway, so what we're going to do is we'll use the trick from before now, because we won't get confused anymore. So we're going to have 2 minus root 3 on the top and 2 minus root 3 on the bottom. And then we're just going to have to do a lot of multiplying out now. So we're going to have 2 times 7 on the top, so that's 14. We're going to have 7 times root 3. We're going to have 11 root 11 times 2. And then we're going to have minus root 3 times by root 11. So if you're just not sure what I've done 1, 2, 3, 4. And that's all on the top. And then on the bottom, we're going to have 2 times 2. We're going to have plus 2 root 3 minus 2 root 3 minus root 3 times root 3, which is 3. And then again, you can see all of our surds on the bottom are cancelling each other out. And then we're going to be left with 14 minus 7 root 3 plus 2 root 11 minus root 33. And then 4 minus 3 is 1. So that's all over 1, which, if you write it just as a normal form, gives us our final answer. Now, this is a good example for showing you that you don't need to always get it in a really nice form where you have two numbers. It's okay sometimes to leave it as a longer answer with multiple different surds in it, because there is absolutely no way that we can cancel this down any further. So this is our final answer in this sense. So I've now gone over everything that you could need to know about rationalising the denominator. So hopefully with the examples that I've given, and then my few little hints and tips for how to not get caught out, that should get you rolling in answering these questions on rationalising the denominator. So I hope you've all found this useful, and be sure to check out any of the other videos if you are looking for any more tips on GCSE Maths.